Let's go to page 771. This lesson is 11.7, and this lesson is to use geometric probability. It says the probability of an event is a measure of the likelihood that the event will occur. It is a number between 0 and 1, inclusive. Inclusive means it means include number 0 and include number 1, and can be expressed as a fraction, decimal, or percent. The probability of an event A is written as P parentheses A. So this is probability of likelihood of an event A will happen. Okay. So when probability equal to 0 means it's impossible for it to happen. And when it's around 0.25 or 1/4, it's unlikely to happen. It may, but it's unlikely. Okay, when P equal to 0.5 means equally likelihood to occur or not occur. Okay. And P equal to 0.75 is likely to occur, but it's not a guarantee. And P equal to 1 is certain. So for example, if I have a coin, right? The probability of, when you flip a coin, the probability of having a head, it would be 0.5, and probability of having a tail is also 0.5. Okay. Now, so it says in previous course, some of you probably know that in like pre-algebra. Okay, so like in pre-algebra class, there is a section on probabilities. Okay, so in previous course, you may have found probabilities by calculating the ratio of the number of favorable outcome. Means whatever the event that you're looking for, the outcome, divided by the total number of possible outcomes. In this lesson, you will find geometric probabilities. Okay. So a geometric probability is a ratio that involves a geometric measure such as length or area. Okay, so key concept. It says let segment AB be a segment that contains the segment CD. So you have the AB containing CD. If a point K on the AB, so if you were to choose a random point, okay, so if you choose a random point on AB, then the probability that it is on CD is a ratio of the length CD to the length of AB. So let's say if you pick a random point on this segment, the probability that the point will fall within this region will equal to the ratio of the length of CD divided by length of AB. Okay, so let's go to example 1. It says find probability that a point chosen random on PQ. Okay, so over here what you need to do is you have to figure out the length. Okay, so PQ is equal to, so what you do is to find the length, right, you use the end minus the beginning. So it'll be equal to 5 minus negative 5. Okay, so that's how you figure out the length. So from P to Q, you use Q minus P. So this will equal to 10. So from here to here is 10. Or you can just count it, right? So from here go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Now when the number is kind of low, it's okay to count it. But if the number is really large, sometimes it's very difficult to count. So you have to know how to use the end point minus the beginning point to get the length in between. Okay? So you want to find a probability that if you choose a point like random, okay, like for example, if you just for example, if you throw a dart, okay, and just land, okay, what is the chance of it landing between RS? Okay, so for RS, so the RS would be equal to, so we use the S would be 4 minus R would be negative 2. And so this will equal to 6. So probability that you would land in RS, the probability that if you choose a random point, okay, between PQ and you just like choosing a random point, okay, the chance though, or the probability that it will land in RS will equal to 6 over 10, okay, or equal to, if you reduce, it would be 3 over 5. Okay. Now, if you use decimal, it would be 0.6. Okay, and if you use percent, it would be 60%. So you can use fraction, decimal, or percent. So either one is acceptable. Okay. Okay, let's go to example 2. So let's go and read through. Okay, example 2. It says a monorail runs every 12 minutes. The ride from a station near your home to a station to your work takes 9 minutes. Okay? So one morning you arrive at a station near your home at 8:46. You want to get to the station near your work by 8:58. What is probability you will get there by 8:58? Okay? Okay, so this is what you need to do is you have to draw pictures. Okay? So what you do is you want to draw the timeline. Okay, like this. So you arrive at 8:46, okay, and you want to be at work at 8:58, okay. So that's kind of a random point, okay. That's the time from the beginning to end, okay. And it says the ride take 9 minutes, so you need to catch the monorail no later than 9 minutes before the 8:58. So it's 8:58. So if you want to be at work by 8:58, you have to catch the train, okay, no later than 8:49, okay. So here's your 8:49. So you have to catch the train before, you know. So here's your, so here's the 8:49, okay, and here's your 9 minutes. So if you catch a train over here, you were able to make it. But if you catch a train over here, you're not gonna make it. You're gonna be late. Okay. So the longest you can wait is 3 minutes, right? Because your train comes every 3 minutes. Okay. So the chance that you will make it is you want to be. That's where you want to be. So be 3 minutes. 1, 2, 3, right? That's 3 minutes. That's what you want. So probability is what you want, okay? What you're looking for, divided by the total, okay? So you need to get in 3 minutes, within the 3 minutes, divided by the total 12 minutes. So the probability or the likelihood is 1/4 that you were able to able to make it, okay? It is 1/4, okay? So again, you got to read the story and draw the picture, okay? Okay, let's go to guided practice. Okay, it says find the probability that a point chosen at random on PQ. So you can PQ. So that's 10. Is on given segment. Express your answer as a fraction, decimal, or percent. Okay, so RT. So this will equal. So number 1. So on the guided practice over here. So PQ, we already did that, is equal to 10, right? So probability of RT, okay, so RT is here, it's 1. So it'd be equal to 1 over 10. Okay, it's 1 out of 10. Okay, so this is number 1. Okay, number 2, probability of TS. So TS, so it'd be 1, 2, 3, 4, 5. Okay, so from T to S is 5, so this will equal to 5 over 10, or equal to 1/2. Okay. Now, if you do the number 3, so number 3, you're looking for probability of PT. Okay. So PT. From P to T is 1, 2, 3, 4. Okay, so again, P to T is 4. But you can just count the squares. Okay, this is a lot easier to count the square than subtract, either way. So it's going to be equal to 4. So this will equal to 4 over 10. Okay, so this will equal to 2 over 5. Okay, now let's go to number 4, probability of R cubed. Okay, so you can look at R cubed. Okay, so from R to Q is 1, 2, 3, 4, 5, 6, 7. Okay, so this will equal to 7 over 10. Okay. So again, probability is what you're looking for on the top divided by the total on the bottom. Okay. So again, PT, so RT is 1, TS is 5, and PT is 4, and RQ is 7. And so that's what goes on the numerator. Okay. And over here, your range is PQ, so that's 10. That goes on the denominator. Okay, so let's deal with length. Okay, now probability can also be done with using areas. So here the key concept, probability and area. It says let J be a region that contains region M. If a point K in J is choosing at random, so if you're choosing a random point, we think choose a random point in J, okay, anywhere over here, then the probability that it is in M is a ratio of the area of M to the area of J. So again, so if you were to choose a random point inside J, the probability or the likelihood that you will inside here is the area of M divided by area of J. Okay? Okay. So now let's go to example 3. Archery. So it says the diameter of the target shown at the right is 80 centimeters. The diameter of the red circle on the target is 16 centimeters. An arrow is shot and hits the target. Okay? If the arrow is equally likely to land on any point on the target, what is the probability that it lands in a red circle? Okay, so let's go ahead and do this. Okay. So there are a couple of ways you can do these. Okay, so first, okay, the diameter of the blue is equal to 80. Okay, and diameter of the red, the target or the bullseye, okay, is equal to 16 centimeters. Okay, wait, I'm going to use, so I don't want you to confuse R as a radius, so I'm going to call this D1, okay, and I'm going to call this as D2. Okay, that way you don't think that it's a radius. Okay, I don't want to use R for the red. Okay, so what's the probability that it will fall in the red? Okay, so probability that it will fall inside the red or the inside here, okay, will equal to, there's going to be a ratio of area, okay, so it'll be equal to pi r squared. Now because of this, right, so R2 equal to 8, and the R1 equal to 40, right? So diameter is 80, so radius is 40, okay? And so over here, so you're going to divide it by pi r squared. Oh, r squared. So the area of the red is pi r squared, and the bottom is pi r squared. Okay. So notice this will cancel out, and if you notice that instead of multiply out, notice you can reduce. Okay. So probability that it will fall inside the red diameter of red circle, okay, it's going to be equal to, notice that if you write it out, notice it cancels 1 and 5, 1 and 5. So probably it will land in the red. Diameter would be 1/25. Okay. Now there's a quick way of doing all this stuff. Okay, because remember poverty is the area ratio, right? So what notice? So if you do this, right? Notice D1 equal to 80. And D2 equal to 16, right? So what you do is find the length ratio. Okay, remember we did this before, right? So the length ratio is equal to 16 over 80. So length ratio equal to 1/5. Okay? Now, the area ratio is a square of that. So area ratio would be 1/5 squared. And so it equals 1/25. And that's that. See that? Okay? So it's the same answer. So that way, you don't want to go through all these. Okay? If you were to use the length ratio and get the area ratio. Okay? So again, probability deal with area would be just area ratio. So once you have the length, first you find the length ratio, and then you square that. Now, if you have to go backward, you take the square root. Okay? So this method is much easier to do than this over here because this can be kind of messy. Okay? Okay, let's go to example 4. Okay, so this is example 3 on page 773. Okay? So again, when you have to figure out probability, it's a lot easier. Just go and find the length ratio, and you square that to get area ratio, and area ratio would be your probability. Okay? That way you don't have to figure out each individual areas of the circle, and then and simplify. Okay, let's go to example 4. Okay, scale drawing. Okay, it says your dog dropped a ball in the park. A scale drawing of the park is shown. If the ball is equally likely to be anywhere in the park, estimate probability that it is in the field. Okay. Okay, so what you do is again count the squares. Okay. So what you do is kind of estimate. So over here, it says find the area of the field. The shape is a rectangle, so area equal to base times height. Okay. So it'd be 10 times 3. So the field over here is 10 times 3, right? 10 times 3, so that's 30 squares. Okay? And then you find the total area. Again, you can just estimate. So it says count the square, there are 40 covered. There are 30 squares in the field and 22 in the woods. So there are 52 4 squares. Now, make groups of a partially covered squares so that the combined area each group is about 1. Okay, so see the part over here, this one and this one is about, this is about 1. Okay, and this is about 1, and this is about 1. Again, so kind of estimate. Okay, so make group of partially covered squares so that the combined area each group is about 1 unit square. So the total area of the partial square is about 6 or 7. So use 6.5. Okay, again, that's about 6 or 7. So they kind of just going halfway in between. So 6.5. So 52 for the complete squares. Okay, plus the partial one come out to about 6.5. So about 58.5. Okay. So now to find a ratio, again, probability is a likelihood of something happen, which is a ratio of the areas. Okay, so it's going to be in the field. The ball is going to be somewhere in the field. So it'll be 30 squares divided by total area of the park, which is 58.5. And again, you can just move one decimal over, so it becomes 30 over 585. And if you reduce by 15, you get that. Okay, or if you use decimal, you just use calculate divide and you get that. Okay. So again, probability, geometric probability can be either be the length or can be area. Okay. So when you're dealing with area, remember it's easier if you know the length, right? You get a length ratio, you square that. Okay. So it is making a lot easier again. So you get the length ratio and you square to get area ratio. Sometimes they give you an area ratio, you have to take the square root to get the length ratio. Okay. So to remember what you learned about the ratios and use that, you can use it to solve some of the geometric probability problems.